13 billion years ago, the process that made our universe began. A process that continues to make our universe ever more complex at an accelerated pace. And we've continued to understand it ever better, going from arguing about whether our universe is 10 or 20 billion years old to now arguing whether it's 13.7 or 13.8 billion years old. We've now acquired a rather detailed understanding of what happened since our Big Bang. This is thanks to an avalanche of high-quality measurements that we've acquired over the years. So let's summarize what we know so far about the past 13.8 billion years of cosmic history. In the beginning, there was light. In the first split second after the Big Bang, the entire part of space that our telescopes can in principle observe was created in an instant. It was all at the time much hotter and brighter than the core of our sun and is expanding rapidly. And although this may sound spectacular, it was actually rather dull, in the sense that our universe contained nothing but a lifeless, dense, hot, and boring uniform elementary particle. Things looked much the same anywhere, and the only interesting structure was what is believed to be quantum fluctuations, a faint-looking sound wave that makes the soup about 0.001% denser in some places. And our universe continued to expand and cool. It grew more interesting, and particles combined into ever more complex objects. During the first split second of the Big Bang, the strong nuclear forces grouped quarks into protons and neutrons, some of which in turn fused into helium nuclei within a few minutes. And about 400,000 years later, an electromagnetic force grouped these nuclei with electrons to make the first atoms. As our universe kept expanding, these atoms gradually cooled into dark, cool gas. For 100 million years, there was darkness. And during this time, it gave rise to the cosmic dawn, when the gravitational forces succeeded in amplifying those fluctuations in the gas by pulling atoms together to form the first stars and galaxies. These first stars generated heat and light by fusing hydrogen into heavier atoms such as carbon, oxygen, and silicon. When these stars died, many of the atoms they'd created were recycled into the cosmos and formed planets around second-generation stars. And at some point, in a tiny speck of the universe, on a planet, a group of atoms became arranged into a complex pattern that could both maintain and replicate itself. So soon there was 2 copies, and the number kept doubling. It only takes 40 doublings to make a trillion. So this first replicator soon became a force to be reckoned with. And thus, life had arrived. This video is based on the book Life 3.0, Being Human in the Age of Artificial Intelligence by Tegmark. If you want to learn more, check out the book in the description below.